A transect is a reference line, of fixed length, put on the substrate. Objects under the line are recorded, sampled, counted or measured. Common lengths used are 10 meters, 20 meters, 30 meters and 50 meters. Lines can be represented by measuring tapes, ropes or chains of different lengths. If conducted by scientific scuba divers, targets of transects are benthic organisms and fish swimming close to bottom. Transects could be performed on both hard and soft substrates. Transects are easy to carry out, only limitations could be represented by depth limits, bottom time, cold waters. There are several types of underwater transects. They are the line intercept transect, point intercept transect, belt transect, chain transect, and the depth transect. In this figure, two scientific dive operators are performing a transect on a horizontal substrate, at the same depth. Transects could be also performed on vertical substrates. This is a frontal view of a transect, here represented by a red dotted line. To carry out a transect you would need, 1. A measuring tape, or rope, or a chain of a fixed length. 2. A dive computer to read depth, temperature, and non-decompression limits. 3. A compass to stretch the line along the same direction. 4. A dive slate and pencils to record bathymetry data and organisms found. It is also suggested using a weighted string called plumb line. Using a plumb line would minimize bias in data collection since the weighted string would fall exactly on the organisms to be recorded. First type of transect that we will describe is the line intercept transect. In a line intercept transect, data are collected along the entire length of the line. In a line intercept transect, only the objects underneath the line are considered. Line intercept transect is used to determine the relative percentage cover of benthic organisms. The precision of this method is high, however, it is time-consuming. Indeed, it requires much time respect to a point intercept transect. Moreover, this method is not appropriate for quantitative assessments of rare and small species. How to proceed: using a measuring tape, start measuring the space occupied by each species, and each kind or substrate, along the entire line. Now, you can calculate the abundance of each item. For example, in order to determine the abundance of coral 1, sum all the lengths occupied by this species and divide the total per the length of the transect. Another type of transect is the point intercept transect. Scuba divers performing a point intercept transect swim along a transect line recording the items only at specific points along the transect. For example, you could decide to collect data each meter, performing a systematic sampling. The abundance of each item will be calculated as number of points where the item has been recorded, divided by the total number of points along the transect. Which method is better? With sufficient points, point intercept transect provides information comparable to line intercept transect. On the contrary, if sampling points are too few, the obtained data could be not representative of the studied population. A chain transect is performed using a tape and an iron chain. The tape is stretched over the studied reef, while the chain follows the exact profile of the organisms. Percentage cover is given counting the number of rings used to profile each organism, and dividing for the total number of the chain. For example, percentage cover of coral 1 is given by the sum of number of rings profiling coral 1, that is 38, and the total number of rings, that is 95. A chain transect also supplies information about habitat complexity. A parameter called rugosity can be calculated by dividing the length of the used chain per the length of a stretched tape. Compare the two examples in the slide. In the first case, the rugosity is higher since the heterogeneity of the benthic community is higher. In the second case, the reef profile is more or less uniform, therefore, the complexity of this habitat is lower. The iron chain should be placed with care on benthic communities, paying much attention to brittle organisms. Rugosity of a reef could be also measured using a digital tool. This method supplies results similar to those obtained using a chain transect. Moreover, the risk of breaking fragile organisms is reduced. In this example, you can see how different are communities with different complexity levels. Among causes of biodiversity loss in tropical reefs, there are destructive fishing methods, use of pollutants, sea storms and tsunami events. Another type of transect is the belt transect. In a belt transect, it is necessary to consider all the organisms present on both sides of the line transect, within a fixed distance. For example, in this slide the line transect is represented by a red dotted line, while the belt transect is the area included between the two black dotted lines. Distance at each side of the line transect could vary in relation to target species. In general, you would consider a total width of 1 meter, or 50 centimeters on the left, and 50 centimeters on the right of the line transect. You could collect records along the entire belt, for example, when you are recording fish. Otherwise you could collect data at fixed points, combining the belt transect with a point intercept transect. To carry out a belt transect, a 1-meter stick could be used to estimate the width of the belt. The dive slate could be fixed on this stick. This table summarizes advantages and disadvantages of most used transect typologies.